Okay, so in this lesson, we're gonna combine together what we learned previously about stoichiometry and chemical reaction equation and how's it happening and the gas law. So let's take a look. When giving these questions, make sure that you understand what exactly it is that they are giving. Usually that's help. Usually look at the unit that will tell you what it is. Okay, so 10 liter is a volume. Okay, so you should know that that's a V. Okay, rigid container. Rigid just mean that your volume is not going to change. This V is going to stay the same, which is important to know. So I'm just going to put it on the side. What doesn't change? Oopsie. So in this case, we said V doesn't change. Okay, contain this many mole of N2, so that's a gas. Okay, mole just meaning N. At 720 T in Kelvin. Okay, temperature, right? Kelvin is the temperature, and then so T is in Kelvin, which is great. We do want a Kelvin. Okay, now 0.234 mole of sample of H2. Okay, notice that we have the same mole but a different gas. Is added to cylinder where the reaction occurred to make this. Okay, so you can already see the reactions happening. Pretty much you have two things happening here. N2 and H2, right? So these two are my reactant because it's that produce this. So this is my product. Okay, so let's try writing this here. Let's try writing a question. Okay, before that, let's see. A, write a balance your reaction. Okay, chemical equation, which is, yeah, we already are guessing. So let's see. So you're going to say N2 plus H2 arrow NH3. Okay, so in this screen computer, I can make them to be subscript. So, but when you're writing it, you want to make it subscript. So this 2 is a little bit below N. So you're writing like that you see here. Okay, this is just example. So take a look. You will notice that in here, what did you notice? Okay, so you should have seen that it is not balanced. Okay, I have a chemical formula correct, but it's not balanced. Take a look. You have how many N here? You have 2N. Here, you have 1N. So that's not balanced. To make it balanced, I need to go to the front of this NH3 and add 2. Oopsie. Now, when you add 2 there, that 2 is belong to the N, so that means you're going to have 2N. But at the same time, that 2 is also belong to the H. So in this case, you're not going to have 2 H's. You're going to have 2H times that number. Now notice that this number is at the end, so it's only belong to the H. Okay, so that in this case, the H will be 2 times 3, which is a 6. So that means I need to go to here and make it 6. It's already have 2, so I'm going to put 3 in the front, and I get my formula. Okay, so N2 plus 3H2 go to 2 of the NH3. Okay. B, how much NH3 will be produced as a result of reaction? Okay, so this is basically your stoichiometry, or back in the day we did, right? So let's take a look here. I'm gonna go down there. We're gonna go to B. Okay, so in B, oopsie, what we're having, we have NH3, okay, will be produced as a result of this reaction. Okay, so how is this happening here? If you are taking a look at this, how much is this is gonna make? First, let's take a look. We here has a mole 0.234. This is also 0.234. Okay, N2 and H2. Based on this reaction, you will see that H2 is gonna need in 3, right? So remember, we talked about this before. It's like, you're making a sandwich. How much you need for each one. So in this case, we need 1 of the N2 and 3 of the H2 for this reaction to happen. Okay, so if we're trying to say, let's see, you're gonna need, let's say you're making a sushi. Okay, you're gonna need, let's say, a spoon of, or no, a cup of rice, and you're gonna have a 3 spoon of vinegar. Okay, so every cup of rice you're gonna put 3 spoons of vinegar, something like that. Okay, so in this case, that 3, right? In my case scenario, cups and spoons are a little different, but here they're more, we're dealing with more here. Okay, so in this case, we know that H2 is the one that's going to run out, so it's an equal amount. Anyway, so now that we know, we're going to get started with H2 first. So we're going to say 0.0234 mole of H2. Remember, this is the part where you have that little train track that we did in our back done, right? So the train track is like this. I don't know if you can remember. It looks something like this, right? You have, I know it's not a great one, like this, and then you put in the number here. So whatever you put here is gonna come down here, so that you can cross cancel it out, and then you put something here. Okay, which I cannot quite do this, so I'm gonna say time and then parenthesis. Okay, so let's see, x parenthesis. So if it already mole, you just have to do mole ratio. Since I want NH3, right, this guy, I'm gonna do 2 mole of NH3 per 3 mole of H2. Okay, so that's gonna give you a mole. Since the question don't really say grams, I can leave it there and I can get my answer. Okay, so this question would have been, to do this, you're going to say 0.234. Since that other 2 is on the top, so you're going to say times 2 divided by 3 mole. Okay, so we're going to get 0.156. Okay, 0.156 mole of NH3. Okay, so let's take a look at C then. So what is C saying? So you go to C is saying how much excess reactant of either of these is left over. Okay, that's rather easy. So we're looking for leftover, so we can go backward. So we know that the leftover is gonna be N2, because H2 was my limiting reactant. Okay, because by the time it's do this, it's already run out. So in this case, if you want, you can go backward. I want to start with the ending, or you can start it with this one. Both the same. Okay, I want to show you both in here. So, oopsie, sorry. So I'm gonna do both here. Why is this? Okay. So the way that we're gonna do it is we're gonna say this more H2, but we're also gonna use this. So let's take a look. How is this gonna be different? So for C, if you use this, then here when you multiply, you're gonna say 1 mole of N2 for 2 mole of NH3. Whether if you do this, you're gonna say time, and then you're gonna say time, and you're gonna say 1 mole of N2 for 3 more H2. This is the only difference that I have. Now, if you are trying to look, the answer would be 0.078. Okay, and this is also gonna get 0.078, and the unit will be mole of the leftover one, which is N2. Okay, I usually separate these when I write these. Alright, so let's see. D said calculate the total pressure in cylinder at this. Okay, notice my temperature change and reaction is complete. Okay, if the reaction completes, what's gonna have left? Well, it's easy. You're gonna have this much more of N2 left, and also since this is produced, this number of NH3 is gonna be there. Okay, so that means now I can kind of do here a little bit differently. That means total mole. Okay, so total mole of gas would be what those two circles that I circled it, right? Because that's how much you're gonna have. Gas don't really care about what kind of gas it is, they just occupy, so you can just add them up. Okay, as long as they're both mole. So you're gonna get 0.234 back. Okay, so next what's gonna happen? Well, that is my mole. Next is you're gonna do use the PV equal to nRT to find it equation, solve for it. Right? Alright, let's see. Do we have a P? No, that's the one that we're solving for. Okay, so we're gonna say PV equal to nRT. P is we don't know. V we know, they give it to you up there. 10 liter. Okay, I'm just gonna say 10 liter. Or you can ignore the number. And N in this case we know 0.234. And then you have your R. R happen to be R is a constant. You should remember that this one's 0.0823, and this is always liter ATM per mole Kelvin. Okay, so as long as the rest of the unit are in that, you can use it. So if you're wondering, this is called liter ATM over mole Kelvin. Okay, that's what it is. And then temperature, notice we're not gonna use this, we're gonna use this new one, 800. Okay, I can write K. You can see your unit will cancel out. K on the top here will cancel with K on the bottom here. Oh, this should say mole. I forgot I say that. But you can see that this mole will cancel with that mole on the bottom. Oh, that's going, I already canceled it. And then this liter on this side will cancel with this liter here. So that means you're gonna have 8 here. Anyway, so if you were trying to solve this, P is equal to 0.234 times 0.0823 times 800 or divided by 10. And you need to remember when you finish, the answer is going to be in ATM because that's the only one left. Okay, so that's pretty much it for how to solve this question. Everything in there should already be reviewed and you already have done it.